Good morning. You're welcome to today's lecture on pharmaceutical calculations. And today we are entering a new topic, rounding, approximation, and estimation. Rounding, approximation, and what? Estimation. Now, somehow we are not alien to these topics. So what I want to do there is just to refresh our memory on what we have already known, then solve one or two things there, and that is the end for the topic. Now, good morning, you are not careful, you will think that rounding is exactly the same thing with what? Approximation. There is a bit similar, a bit difference between the two of them. Have you heard of the word rounding? What comes to your mind whenever you hear the word rounding? As if you are asked now, what is rounding? What are you going to say?
Rounding to the nearest. Normal sense goes to the nearest whole number, the nearest thing.
To the nearest whole number. Good morning. To the nearest 10. What do you think?
Like to each factor number to the smallest digit.
To the smallest digits. How?
Like each factor the number.
What of approximation? What comes to your mind whenever you hear approximation? Are they the same thing? No, if you have a superior argument, why not? I'll go by your own. But do you think they are really the same thing?
Like similar. They have like similar something.
But do you think there's any difference between rounding and approximation? Okay, there's no difference.
According to me, there's no difference.
I can tell you.
Yes, sir.
Okay, that's good. If you have, what do you think?
Rounding up, kind of similar.
Is what?
Rounding up and approximation.
Are they the same thing? Is there any difference between the two of them? Rounding and approximation.
Yes.
So tell me the difference between two of them.
In rounding up, you can round up to the nearest whole number. But in approximation, kind of, they have to approximate to two decimal. Two decimal
You approximate to the two decimal places. Do you round to? Or do you approximate to? Come on.
Like if number is 9.8.
Let's assume we have. Let me pick an example now. Yeah, good morning. Good morning. If you have something like this, 98.38. Now, if you are told now to if you have 98.4, what have you done? To what? You appropriate to what? One decimal place. Now, what do we have you have 98.42, and you end up having, after whatever you did to it, you have 98.4. What have you done?
You have rounded up.
What have you done?
Since the number minus 1 is 1.5.
Okay.
Yeah, you know it is
So what did you do?
rounding up. Our estimate. Rounding up. That is
Approximation.
estimation. Estimation.
Approximation.
Hmm?
It is approximation.
Is what? Is what? Round up, round down, approximation,
Estimation.
estimation. Come in.
They are similar.
Hey, go and knock your tie well before you come in here.
Good morning.
Good morning. Good morning. Go and do it before you come in. Okay? Now, do you think it's every... That is your business. Don't enter this class without that tie. Well, not. Now, we have rounding, approximation, estimation. Now, let me now say something now. Sometimes you can be told. Good morning. Come in. I want to list some things. Significant figures. Decimal places. Maybe whole number, integer, and whole number, integer, you have 10, 100, 100, say tenths, and the rest of them. Now, if you are rounding, if you are rounding, you round to significant figures or decimal places. Am I communicating? You round to significant figures or what? Decimal places. Now, but if you start going deeply, they are the same thing. Hope you know. But I'm pointing out the slight difference between the two of them. Approximation is more specific than what? Rounding. Now, look at this thing now. Are you aware that under decimal places, you can have 10, 100, tenths? Are you aware? Yes. Because you have thousands. You're going to have 1,000. Are we together? Now, when you just say, if you want to say, maybe you want to say put a number to a particular decimal place, simply say round to what? To 2 decimal places or 3 decimal places. But approximation now, coming. Approximation now names that what places you are putting that number. Am I communicating? It names that places. Like now, 1,000. What decimal places is 1,000? 3. 3, right? Yes. Is it 3? Check well. Is it 3? Is it 3 decimal places? Hey. Okay, thousands. This is thousand, right? How many decimal places? 3, right? Thousands. Now, tenths is what? 1 decimal place. Are we together? Now, you can round up. You can also round what? Down. Are you aware? No, you today. You can round up and you can round down. Hello? Now, if you say, if you want to round, let's assume you have, let me use this one now as an example now. If you have 98.34, 98.38, sorry. If you have 98.38, maybe you were told to round to 1 decimal what? Place. You have 98.4. In this case now, you actually rounded up. You rounded up. See why you rounded up. You rounded up because the digits in the decimal place upon which you added 1, whatever you get is now higher than the digits of that decimal place initially. Initially, in the one decimal place, we have what? 3 here, right? But after the rounding, what you have here is now what? 4. Is now what? 4. Hello? Any question? Okay. Now, what you have there is now 4. Or to understand it better, if you round up, to understand it better, if you round up, the value you got after rounding up is always higher than the initial value you started with. That's round up. Now, 98.4 and 98.38, which one is higher? 98.4. So, if the value after the round up, after the rounding is higher than the value before the rounding, is called what? Round up. But if the value after the rounding is less than the value before the rounding, is called what? Round down. Look at this place now. Initially we have 98.4. But because this 2 is not up to 5. Hello? This 2 is not what? Up to 5. We discard it, right? Yes. And put it here, right? Now, what you did, the final value is now what? 98.4. 98.4 coming. 98.4 is less than 98.42. What you just did is called what? Round down. You rounded what? Down. Hello? You rounded what? Down. Good morning. Is it clear? You see now, but in approximation, all you know is that we just focused on what? They're not like approximate up, approximate down. Am I communicating? Approximation is what? Approximation. You are not being specific. You can approximate to a particular, maybe you can approximate to the nearest integer, nearest 10, nearest tenths, nearest hundredths, nearest whatever you want to approximate to. But if you are rounding, you actually rounding, either you round up. When it comes to what decimal places, either you round up or round down. Now, you also, when you talk of significant figures, what you do there is what? You round to what? Nearest to maybe to a specific, maybe to, let's assume you want to round to two significant figures. So we'll see discuss significant figures when we go to what topic again? Yes, it's here. We'll talk about it. Significant what? Figures. You understand what significant figures is, okay? But I just mentioned it at a passing. I just use all this to distinguish between what? Approximation. So under the rounding now we'll discuss decimal places and what? And what? Significant what? Figures. Good morning. Under the rounding, we discuss decimal places and what? Significant what? Figures. Even though this word, the two words, you see them sometimes interchanged. Am I communicating? You see them sometimes interchanged, and we accept it, but they're not exactly what. There's slight what difference between the two of them. They're not exactly the same thing, but in usage, you just see sometimes you see people saying, okay, even some textbook approximate to 2 decimal place, and we just take it like that. But in real sense, if you go to the word itself, it's not exactly what the same thing. Okay. Now you employ approximation. From this approximation came from approximate numbers. Approximate what? Numbers. Approximate what? Numbers. It came from where? Approximate numbers. Now take a look at this. Numbers that are not absolute. A number can be absolute or it can be what? Approximate. Are we together? Number can be what? Absolute or what? Approximate. Most of numbers that are absolute are mainly counted. Come in. Counted numbers or count numbers. These ones are mainly measured. Approximate numbers are mainly what? Measured what? Numbers. Even though there are some, like now there are some discrete number. You can also liken this to what? Discrete numbers. Are we together? You can also liken this to what? Continuous what? Numbers. Are we together? You can liken this approximate to continuous numbers. You can also liken this. Even though you cannot count 0.85. Can you count 0.85? Can you count 0.85? Can you count it? Can you count it? If you have a very big material now, can you actually divide it into and get 0.85? Is it possible? Put the 0.85 in common fraction. Put 0.85 in common fraction. Get it to the smallest thing. 17 over what? 20. 17 over what? 20. Can you get 17 parts out of it? Is it possible? That means you can get something now and divide it into 20, right? And get 17 out of it. It's a fraction anyway. It's a fraction, right? Can you count half? Can you count half? You cannot count half, right? So, but are they really approximate numbers? Is 0.5 approximate number? Are you sure? Is 0.5 approximate? So is 0.5 approximate number?
No, it's absolute number.
You came late now, sorry. Next time you come on time. Now, I just want to estimation. I'm having an overview of this topic. See, there's something I want us to know. Listen carefully. My target is that every week I must cover one topic. That's my target for this course. At least one topic. I may cover up to 2. So I want us to really take it seriously. Let's be coming to lectures on time. Is it because I came late yesterday? That's why most of you relax. Most of you just relax. That's bad. Come in. That's very, very what? Bad, okay? No matter what, your lecturer should not be in the class before you. No matter how you want to put it. You're meant to be in class before your lecturer comes in. That's what it should be. No matter what it is. Now, if because of this issue of coming late, I'm not able to cover a topic in a week, sorry, you may have to go and do what? Read it up. Let's continue now. Coming now. So under rounding, we will discuss single figures and what? Decimal places. That's what we talk about here. Under approximation, we look at how you can approximate maybe to a nearest whole number, nearest integer, nearest, what is it called again? Nearest 10, nearest tenths, nearest whatever, specific what? Place value. Nearest specific what? A specific what? Place what? Value. You can be asked to approximate the nearest integer. They failed this in work last year. You see someone that's supposed to know the integer we need in this class. This person doesn't know that. How to now approximate to the nearest what? Integer. Maybe asked to approximate to the nearest 100, nearest tens, and all those things. No, that's what we do here now. Under estimation, what happens in estimation is this. Estimation is not, it's an estimated value, is not an exact what? Value. In estimation again, you will need the knowledge of place values to be able to do what? Answer questions in what? Estimation. You need your knowledge. In fact, your place value is the foundation for anything you are estimating. Maybe you may have 2,478. You may have something like this: 2,478 times 4,847. Even though you do not punch your calculator or do the calculation, get the actual value, you can estimate where it should be. First of all, you can estimate the place value the answer should be in. Are you aware? You may look at this number, these two numbers, and this thing now, and estimate the place value it should be. Then, on the estimation now, when you ask question in estimation, be careful. Don't be tempted to go and start punching calculator and give me answer, actual value. You fail it. That is not what? Estimation. You calculated it. It's a calculated what? Value or actual value. Estimated value should have a lot to do with the what? The place value. That the bedrock of whatever answer you are going to get there. Now, this 2,478 times 4,847. If you look at this thing now, you don't need to put it. I can estimate this as first of all, the place value should be in 1, 2, 3. 1, 2, 3. In what? Million. It should be million in the first place. So if you are to estimate this now, whatever you are estimating should be in what? Million. That's the first thing you should know. What is the place value of the first one?
1,000.
What is the place value of the second number? 1,000 will give you what?
Million.
Think. Do you know your problem? Let me summarize your problem for you. Listen carefully, Andy. If I summarize it, start working on it. It's a very big problem. Children of these days lack reasoning. It's a very big problem. You be given something, A is B. A is C is equal to C. Then you'll be told A is equal to C. You'll be told B is equal to C. How, sir, how? That's the problem. If you tell the truth, you know what I'm talking about. You'll be told that A is equal to B. A is equal to C. Then in the exam, you'll be asked B is equal to what? They didn't teach us. It's a very big problem. But it's a reality. Unless you go and start setting that same A is B, that's when you have taught us. You are here since I told you, I made the first statement. I said this is built up on what? Place value. Good. Will you tell me that you don't know that place value of this is 1,000? You are aware. And this is multiplication. You are aware. I know that this one is 1,000. I now said million. You say how? I don't understand. Now, I now ask you two simple questions. You answered it yourself. What's the problem? Reasoning. Don't think. It's a problem. Oh. You may feel bad about what I'm saying, but it's a reality. I don't know what's going on. Calculation is all about what? Thinking and what? Reasoning. Simple. It's there to help you. And as a pharmacist or pharmacy technician, as case may be coming, you must learn how to do what? Reason out, think out. Because what you see, some cases you will see will not be in any textbook. True of us, directly the way it is from what you see on ground and from knowledge of what you got from textbook, you can now infer. True of us, and take care of that what? Situation. Everything must not be the way it is in the book for you. Think out of the what? Box. And the moment you get to this level, that means you are trying to do something great with your God-given brain. I said that this thing is, the bedrock of this is what? Place value. So if this one, if the place value of this is, maybe I want you to estimate this. Then after estimation, you are getting a number in hundreds of thousands. You will see your time, only him. True of us. You did nothing. And the first step is that it should be in what? Million. Then let us now look at it. See how, okay, did you take care of the digit well? Did you get the digit well? But the basic thing is it should be in what? Million. So now, by power of estimation, immediately you look at this on a palm. You have already known that this answer should be in what? Million. You may punch your calculator and make mistake. And because you have estimated it before, you know exactly where the mistake is what? Coming from. Now, these are what you will expect to see. So we do estimation in the four operations: addition, subtraction, and what? Multiplication and what? Division. That's what we do in all these in estimation. So this whole thing is what I'm going to do in this topic. So by virtue of where I am now, what I've said now, I think this topic is as good as what? Done.
No.
I just mentioned the place value where the answer should be. And we have not done the proper estimation, okay? Okay. But if in estimation you're able to get you're able to get this first, second, I think you have tried. You can work on first, second digit, and they round this one, you have tried. You can get maybe around this and this, you give 8, right? Maybe around Yeah, so something like that, or 14 million. If you get a source, you have done what? Estimated. Hello, you have done what? Estimated. Now, you wanted to ask a question. Who? Yeah.
Like, throw more light on that rather than approximation.
No, I will not.
Why?
I will not. I cannot come here before you. Then you came in late. You start asking me to go back to what I've said. I will not do that. Lie. I can only answer. If you ask a question, I know where you know. I know when you came in, and I know the type of question I can answer you. That's the punishment for coming to lecture today. Ask a question. Let me hear you.
What of if they give you something like 2,000 for, they give you the first number, then the second one is maybe 840 times 847.
Okay, first number is what?
Let me just say 2,478 times 804.
84.
Yes. No,
Okay,
804. 807.
807.
And the tell you to approximate.
Approximate or estimate? Yes.
Okay, how do you?
If you look at this thing, if you look at this thing now, you don't know that this thing should be in hundreds of what? Thousand. The value should be in hundreds of what? Thousand. You don't need to be told. First one is in thousand. Second one is in hundred. Multiply them, it's in hundreds of what? Thousand. The basic thing that it should be in hundreds of thousand. Now the actual, is it 270,000 or 300, and depending on the values we are here. It depends on what you see here. Okay? Don't worry, we'll solve questions on that. You understand that better? Ask. We are just having a kind of an overview of what we expect to see in this topic. Okay?
Like if you ask us a question, maybe this semester or exam, you give us a certain number, we should give it a place value. Is it just the place value setting, or we write the exact answer of the number and then give the place value?
The place
Are
value.
you focusing on just the place value, or you write the actual answer and get the place value?
No, okay. You mean the estimated value?
Like for instance, now you gave us this 2,478 times 4.
And say that you should estimate it. If you estimate it in a bracket, the actual value. Am I communicating? You can estimate it and write in bracket actual value. No, the actual value is actual value of 2,478 times this. Whatever value it will give you is the actual value. But the estimated value is the one you estimate. Apply your knowledge of place value.
Like what write it, like for instance now give us a question like we want to write the answer, we'll just say the estimated value is million. No wrong. So just write.
No, once I see it, I will know the estimated value. Just write the estimated value. Maybe let's assume that the estimated value, like I'm here now. If the estimated value of this one now, let's assume is 12,500. So 12.5 million. For example, now let's assume it's 12.5 million. Punch this and this is 12 million what?
1,010,210,000.
This time this is what?
1,210,000. 12 million.
Multiply.
Sorry. 12 million. 12 million.
Let's assume
12 million. 10,000.
now look at this. Maybe after estimation we got 12.5 million, for example. This is the estimated value. Then in bracket, actual value is what?
12 million.
010. 800 what?
66.
Many guys I know that this is the estimated value. And this is the what? Actual value. Yes. This is the estimated value. This is the what? Actual what? Value. How will you know? How will you know, or how will I know? That's the question. Is it you know it? Is my know it now? You are always to do what? Write your answer like this. If I see it, I know. If I see it, I know. Everyone, wait. Hello. So. Ask your question again.
Like the actual value is 12,000. 0 1 the opportunity your actual value like 12,005 million.
This is 2.5 million. 12.5 million. This may be the expected value. For now, I say for example now, if this is your expected value, in bracket write your what? Actual what value.
Okay, so now that this is the actual value, what is our expected value? You know you wrote 12.5 because you didn't know the actual number yet. So now what is the expected value?
For this one?
Yes. Based on the actual value that we got.
Okay. No. If you look at it now. Now, one thing I want you to know is this. Your expected value, note this point. You know here now, here the actual value is in millions, right? Good. Your expected value, the difference between your expected value and your actual value, your expected value should not be less than the actual value by more or less than two place values. See what I mean? You know, if you have, for example, if you have 120,000 108 or 010, for example now. 120,000. Yes, this one is in million, right? Yes. This one is in what? Hundreds of thousand, 100,000. This is million. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. This is million. This is what? Hundreds of thousands. Now, basically, the first thing to notice is that they should be in the same place value first. Hello? They should be in the same what? Place value. That one is sacrosanct. You can't tell me that you're estimating something and what is estimated is in 120,000. You say you're expecting something in million. It cannot work. Are we together? They should be in what? Place value. That one is sacrosanct. Now, inside that place value now, look at the smallest place value in here now is what? Is what?
6.
Is what? 6, right? 6, which is tenth. This is unit. 10, 100, 1,000. Then subtract 2 of them being in the same place value. Subtract this 120 million from this. You have what? True or false? So that 12 million from this now, what to give you? Good. Now the difference between on the same place value now is we have what? 10,866, right? This is now. If you now anything you approximate should either be you have a number on top of it that should be maybe in this is 10,000 should be in 1,000, maybe that is 1,806, or in 100, maybe 108, for example now. Whatever you have on top of it. So if you estimate 12 million, for example now, this thing I estimated here now, 12.5 million. If you watch 500,000 is here, right? If you watch compare 500,000 and the 10,866. This one is in what? 100,000, right? Why this one is in what? 10 of thousand. After 100,000, can you get 10 of thousand?
Yes.
You can estimate this to be what? 12.5 what? Million. Is acceptable. Is what? Acceptable. Yes. It is what? Acceptable. You can estimate it to be, but it should not be more than this. Like, because if you check on top of this now, you can have this is tens of thousands. You can have hundreds of what? Thousand on top of it or less than it. Okay? Now, the basic thing you should understand is this. The underlying word there is that this whatever you're estimating, if you get your actual value, it should not be in a decimal place that is two places, more than 2 places above or below the what? Actual what? Value. It should not be more than 2 places above or below the what? Actual value. So whatever if you get this now, you can't tell me that maybe you have, but as you are doing that, ensure that the baseline is that they are in the same, basically they are the same what? The highest value, the highest place value for two of them must be what? The same thing. Hello? First thing you should know that the highest value for two of them, highest place value for two of them must be in the same place value. Highest value. Now, when you now come in, whatever you have on top of it should not be, the difference between the two of them should not be more than 2 above or what? Below. See what I mean here? Hello? I said here now, we have 12,500,000. Here you have 12,010,000. 12 million what? 10,000. Now, if you have, even if you have simply 12 million, bam, is a correct what? Estimation. Are you there? If you have 12 million as your estimation, is a correct what? Estimation. If you have 12.2 million, I will mark it for you. But if you go and start having 13 million, 13 million is somehow funny, right? It's somehow funny. I will mark it for you. If you have 11 points, listen carefully. If you have 11.8 million, I'll mark it. Yes. 10 million. No. He said no. He said no.
Is it as information?
Actual number is actual number now. That one is actual number is fixed. True or false?
Yes.
Your estimation may not be the same thing. That's what I'm making. When I wear the exam, when I end the same estimation, something is wrong somewhere. You can never have exactly the same what? Estimation. It's not possible. Something is wrong somewhere. The both answer. No. I'm searching.
If I get my actual 11,100,000, and the estimation.
No, that is calculation. It's not estimation.
Okay,
You say what?
My actual.
Okay, you get. So you get.
You say what?
My actual value, if I get 11,900,000.
Yes.
And my estimation of 12 million.
In your actual value, you got what?
11,900,000.
Okay.
And my actual estimation of 12 million.
Perfect.
Wow.
Perfect. I'm not guessing. Hello. Someone's asked is the estimation guessing. Is he guessing? Are you guessing? Am I guessing? Guessing, okay. We have rule. We have following. Yes, two of us. Yes. And instead of maybe you're waiting for me to come and say, "Oh, yeah, pull down the rules." Rule number 1. You're wasting your time. Hello. Let me tell you one secret. Hello, listen. Let me tell you one secret. Let me tell you one secret about my class. So, in case you don't know, you don't play in my class. If you play, you keep failing. Because as you are there playing, lecture is what? Points are being made. When you see your neighbor's note, you say, when he say all these things? When? How? If you are in my class, please, maximum attention. I've listed up to no less than 4 rules here now, 2 of us.
Yes.
If you're following this lecture, I've listed no less than 4 rules here, but you don't know. You're making noise. You're not listening. You're not writing anything. You are playing. You are playing. You're supposed to announce, "Oh, yeah, right. 4 rules." It's not true. I don't do it. Because if I do it, you turn and making it. After making it, you turn. When you hear "Oh, yeah, right," you focus and keep. No, I don't do that. You must sit down and listen to my class. So I've set up to 2, 3, 4 rules now you must follow, and things you must not do. So it's not a guesswork. Anything that has rule is not a guesswork. 2 of us, you must apply those rules to be able to do what? Get it right. So it's not a guesswork. If a guesswork, that means you can close your eyes and say, "Okay, let me just write 1." You write 1. I am guesswork. I said that the first thing you should always notice that whatever you are approximating, whatever you are estimating, your estimated value and your actual value, their highest placed values must be what? The same thing. That one, the first thing you should always know. You can't say that you have actual value in 1,000 and you're estimating in 100. You're wasting your time. What do you mean? 2 of us, you don't do anything. Now, after that, next thing you should check out is this. If two of them, like as I said now, I do ask a question. If what of 12 million? 12 million. If she estimated 12 million, and the actual value, right? 11 point what? 11.9 what? Million. Now, the first step is this: are they in the same place value? Yes. Their highest value, are they in the same place value? Yes. They are, right? Yes. Now, what is the difference between this 900,000 and this? Is what? 100 what? 1,000. Now, if you check this 100,000. If you check this 100,000, if you watch, the difference between 2 of them is what? 100 what? 1,000. And this one is what? This is the actual one, right? Now the one on top is what? 100,000. This thing now is, if you have, I remember I said that it should not be plus, above, or less than the what? Actual value. Less than or above the actual what? Value by the what? What is on top of the what? Actual what? Value. If you watch now, here is what? 900,000. Here is what? 100,000. These two are in the same what? They are the same what? Place value. That's why I shouted what? Perfect. Are you there? That's why I shouted what? Perfect. If you have something like sometimes maybe if you have 12 million, let's assume you have 12 million 900,000. Even though I may just close my eyes, watch out. 900,000 minus 12.9 million minus 11.9 million is what? 1 million, right? Right? Good. Their highest place value is what? Is what? The same what? Million, right? 1 million. Now, I may just close my eye and do what? Mark it. Hello? I may just close my eyes and mark it, but it's not a wonderful what? Estimation, but it's not totally what? Wrong. But it's not a wonderful. You know, the closer it is to the destiny is better. Okay? The closer to the value is what? Better. But if I am 30 million, you are wasting your time. Are we together? And you are just wasting your time. If you watch, why is it that it's not a good one? Is that this one is close to what? It's closer to what? 30 million than the what you have value. But based on the rules, if you estimate that, I will mark it. Am I communicating? Good. Now, see, if you know the rules, let me not talk too much. If you know the rules, you don't need to stress yourself. True of us. You don't do what? Stress yourself. Answer.